On Wednesday, we looked at more multiplicity of zeros. And if you don't remember from the last video or class, multiplicity is the exponent above the factor. So when I say multiplicity, we're not looking at the factor itself. So like for this factor, the multiplicity is 2. For this factor, the multiplicity is 1. On the right, for this factor, the multiplicity is 3. And then we follow the 2 rules at the top of the page. So if it's even, we know the graph hits the axis, x-axis, and turns around, or bounces. I just write bounces because I want to write a little less. If the multiplicity is an odd number, then it crosses the x-axis. So on Monday, we factored these at the very bottom of the page. We got this, and we said x equals -3 and -5. Now we can say more about each of these zeros, about each of these x-intercepts. So since the exponent above each parenthesis is a 1, it's not written, but it's there, right there and there. We know that the multiplicity of both of those is 1, which is an odd number, which means the graph crosses. On number 2, very similar scenario. We had 2x plus 1 and x minus 4. So we had 2 zeros at -1/2 and +4. Both have a multiplicity of 1, which is an odd number, which means the graph crosses the x-axis right there. All right, last one. It was a little different on this one. We took out a GCF of negative x squared, and then we factored it to x minus 2, x minus 2. Now that x minus 2 is written twice, so you can combine it into 1 squared, which is important because we want to talk about its multiplicity. So we had 2 zeros here, 0 and 2, which both happen to have a multiplicity of 2. By the way, each 0 could have different multiplicity. So like up here in the middle of the page, x equaled 1, that has odd multiplicity, it crosses. This one right here has even multiplicity, so it bounces. So it doesn't have to have same behavior for all the zeros. It's just a coincidence on these problems 1, 2, and 3. Trying to show you a good mix. But 2 is an even number, meaning the graph bounces at both of those zeros. So we'll look at what that means, like what that looks like in an actual graph here in a minute. All right, moving on. We worked number 4, just more practice, identifying multiplicity. Number 4 is already factored for you. You just got to describe the zeros. So x equals, or let's do this. I'll write it a little different. And in x minus 5, that has a multiplicity of 1, and that's an odd number. We have multiplicity of 3, which is an odd number. And we have multiplicity of 4, which is an even number. So when I actually write down my answer, it looks like this. There's a 0, and it crosses. There's a 0, and it also crosses. And lastly, we have a 0 at 1/4, and it bounces off of that one. So let's go ahead and practice. Let's look at what this graph would look like. If I was to sketch this graph, I'd make some dashes for 5, -2, and 1/4. So 5's way out here. -2, I don't know about there. I'll make a dash for a 1. And then let's make some dots. So 1/4, that's about right there, and there. And then we got to combine our ideas from last week, end behavior, so I can start the graph. I see the front number is positive, and this 4 right here will make this be x to the 4th times x to the 3rd times x. That gives me x to the 8th. So I have an even degree and a positive front number. That means this thing is going up and up on the left and right sides. And then we can use the crossing and the bouncing to finish out the graph. So I know at -2 it crosses. It turns somewhere, comes up, bounces off, turns somewhere, and I'm guessing here. Those dips there may go way lower. I don't know where exactly it crosses the y-axis. This is just guesswork using only the x-intercepts in behavior. So we'll be a little bit more precise later. I just want to give you a picture of what this crossing and bouncing is. Let's practice another problem. Let's find all the zeros and describe them. I see 4 terms. If you have 4 terms, one method that sometimes works is factoring by grouping. So you set it equal to 0. You group the first 2. Group the last 2, but let's put a plus sign between them because we're not multiplying any of these terms yet. And once you have your 2 groups, you try and take a GCF out of each group and hope that the leftover is the same for both terms. So what I mean is, in this one we could take out an x squared, and we have an x plus 3. On the next one, I could take out a -1, and I also have an x plus 3. That was the goal. Factoring by grouping doesn't work if you don't get 2 parentheses that are identical. Then factoring by grouping just doesn't work for that problem. But it does for this one. So what you do is you take that x plus 3 out, and I have an x squared left and a -1. Then you can take it even further and factor that to x plus 1, x minus 1. And for this problem, it looks like they all simply cross the x-axis because they all have a multiplicity of 1, which is odd. They all cross the x-axis. Oh, I didn't actually write down my zeros, did I? X equals -3, 1, and -1. All cross the x-axis. All right, let's try one more and we'll call it a day. So full problem right here. We're going to do all 4 steps. We're going to graph this thing. Step 1 is last week's work, end behavior. Step 2 is what we learned this week. And 3 and 4, you already know how to do. Step 3, I'll remind you. And step 4, I haven't talked about yet, but it's very simple. So n, remember, is your largest exponent. Or degree. And in this problem, it is 4. Sign of the front number is positive. And then you move to left side, right side. Hopefully you have it memorized, or if you don't, look at that table we drew a few days ago, last week. We have an even degree. We have a positive front number. That means since it's even, the behavior is the same on both sides, and it's going up because it's positive. For x-intercepts, I need to factor or solve for x. So I take this equation right here, and I start factoring it. It looks kind of weird because it has x to the 4th, but remember, x squared times x squared gives me x to the 4th. So that's the first step. And then you just find 2 numbers that multiply to 1, but add up to -2. And we got it. Now it's not finished. We can break that down. And then in terms of multiplicities, we have 2 of each. Hopefully this all makes sense. It's pretty much all review except for this multiplicity thing. And I see a multiplicity of 2 that's even. That means it bounces. Let's find the y-intercept. And remember, you do that by plugging in 0. So I'll do that over here. And you can already see it. No work really needed on this one. It's just a 1. Turning points, step 4, that's n minus 1. So how many times the graph turns? For example, if we had a quadratic function, that's just a parabola, and it turns 1 time right there. So notice the degree is 2. It had 1 turning point. Turning points is n minus 1. So in this problem, it is 3. All right, let's graph this thing. We have coordinates at those 3 spots, so make a dash right, a dash left, a dash up, and make some dots. Then let's do our end behavior. I see left side is going up, and that's right above the left 0. Right side is going up. And now I just follow the bouncing pattern and make sure I cross all the coordinates. All right, so I'm gonna scoot this arrow over because I'm gonna miss the dot. So it goes down, bounces, cuts through, bounces, and comes up. All right, hopefully that made sense. See y'all later.